Yeah, recording is on. Good. So in the previous stage, first of all, good morning to all of you. This is Vipul, and we are dealing with our first unit of discrete maths. And that first unit, we are going to end this first unit today by the end of the day. And today I'm going to take one more session, as I said just before. The last session of the day, that is 2:55 to 3:55. Actually, that session is of Twinkle Ma'am, but today I'm going to take care for that, is it? And the separate link will be shared with all of you within a short time for the last session. So I will request all of you to join that particular session on time once again. Okay. Now let's continue with this session. We all know that in the first unit is divided into two parts. Logic and predicates. We are done with the logics. Now we are supposed to do with the predicates. Now what we mean by predicate? Predicate. We had already discussed that definition yesterday. A predicate is a declarative statement whose true value, true or false value, depends on one or more variable. Might possible that we are using predicate with the single variable, then the form of that predicate will look like this: p of x, where we are having just single variable x. Quite possible that we are dealing with the declarative statement with more than one variable, x and y. Might possible that we are having three different variable x, y, and z. So all those are predicates. If it is a declarative statement, which depends, whose truth value depends on one or more variable. Let me give you some of the examples of predicates. Here is this. Okay. Predicate with one variable denoted by p of x, as I just said. Predicate with two variables will be denoted as p of x comma y, and so on. If we are having three variables, then I will be using the notation p of x, y, z. Take example there. Suppose the similar example we were dealing with the previous session, that p of x. Suppose I'm declaring one of the statement like that, x is divisible by 7 now. Surely one can easily determine thus the truth value of this statement. Depends on x. This purely depends on x. Okay? Whether x is in multiple of 7, then the truth value of this statement will be true. If x is not the multiple of 7, if we are gonna pick any of the random number which is not in the multiple of 7, then surely the truth value of this declarative statement will be false. So the truth value of this declarative statement is depending on the single variable right now, which is x. So yes, we may label this statement as predicate, is it? Here x is variable and x is divisible by 7 is known as predicate. Now the predicate p of x is also known as propositional function of x. Instead of using the predicate, we may use this particular labeling, that propositional function of x. It is surely a function related to x. We may use this notation, propositional function of x. So let assign some of the value to this x. If I'm going to assign x as 1, then 1 is divisible by 7, then surely that statement will have the truth value false. If I'm going to assign x as a 2, अगर मैं x की value assign कर रहा हूँ यहाँ पे, if I'm going to assign x as a 1, then p of 1, that declarative statement will look like this: 1 is divisible by 7. Now one can easily decide this is the truth value of this declarative statement is false. गलत है. If I'm going to assign x the value x 2, then the statement will look like this: 2 is divisible by 7, which is also false. If I'm going to assign 14 to x, the value 14 to x, then the statement will look like this: 14 is divisible by 7, which is true. Or if I'm going to assign x as 7, then 7 is divisible by 7, वो भी सही होगा. So बहुत ही आसान है. देखिए, the truth value of this statement is depend on x. So yes, this is a predicate. This is what the definition of predicate is. क्या बोला था हमने definition में? predicate is actually the declarative statement whose truth value depends on one or more variable. Right now we are dealing with the predicate with the single variable. Quite possible we will be in the next example we'll be dealing with the predicate with the more than one or more than two variables, is it? So if I'm going to assign x as 14, then surely the truth value will be 2. P of 14 is true. If I'm going to assign x as a 5, then 5 is divisible 7. That will be the statement, that will be the predicate, and the truth value of that is false. P of 5 is not true, is it? One more example. Suppose let's deal with the, let's stick with the single variable once again. P of x, I'm giving my declarative statement as x is a prime number. X is a prime number. Now if I'm going to assign number 3, if I'm going to assign x as value 3, then 3 is a prime number. What do you think? Yes, it is correct. It is true, is it? So P of 3 is true. If I'm going to assign x as a 14, then 14 is a prime number. That is a senseless, is it? It's wrong. So P of 14 is false. So these are the predicates with the single variable. Let me give you some of the predicate with the two variable and beyond this. Px comma y. Now this is a propositional function with the two variable. Mind my words, as I say that you may use that notation also, propositional function, is it? This is one of the propositional function with two variable x and y. Now the declarative sentence is something like that: 2x plus y is divisible by y square. 2x plus y is divisible by y square. Now don't worry about this particular statement कि ये मैंने कहाँ से उठाया है, ये मैंने बनाया, खुद से बनाया, ठीक है? 2x plus y is divisible by y square. That is one of my declarative statement. I'm declaring some of the thing, one of the statement, that 2x plus y is divisible by y square. Instead of using this, you may use this x plus 2y is divisible by x square. आप ऐसा कोई भी statement, कोई भी example बना सकते हैं, ठीक है? It's purely dependent on you. Or you may write like this: x plus 2y is divisible by x plus y, or x plus 2y is greater than x square plus 2y. Any of one of the declarative statement we just need. Now, if you focus on this, if you're going to compare both this and this, one can clearly observe that here in this particular predicate I'm using two variable. In this predicate I'm using single variable. So the truth value of this declarative statement depends on the single variable only, and here the truth value of this predicate is depending on two variable x and y. Truth value depends on two variable x and y. So now the way we are gonna assign the value of x and y, based on that we may decide whether that propositional function with two variable x and y is gonna stand true or false. So let's assign some of the value. If I'm going to assign x as a 1 and y as a minus 1, let me assign x as a 1 and y as a minus 1. I'm going to take x as a 1, y as a minus 1. Okay? Then simplify this. 2, 1 plus y. 2x plus y, I had assigned x as a 1, y as a minus 1. So 2 1s are 2 plus minus 1. 2 minus 1, it will be 1. Will be 1. So 1 is divisible by y square. What is my y square? Y square is y is minus 1. So y square will stand 1. So 1 is divisible by 1. Yes. So the truth value of p1 comma minus 1 is true. Is true. Is it? I can say that is true. Thus p1 minus 1 is true. Similarly, if I'm going to assign x as a 2 and y as a 3. If I'm taking x as a 2, y as a 3, then 2 2s are 4 plus 3, 7. 7 is divisible by y square, y is 3, so y square will stand 9. 7 is divisible by 9. Now, this is wrong. This is wrong information, wrong declaration, is it? So 7 is not divisible by 9, so I can say that P of 2, 3 is false. The propositional function with two variable 2, 3 is false. Now, one can easily understand that the truth value of this predicate depends on two variable. Now the things depends on both the variables. Now the biggest question is that from where we are supposed to pick both that variables, from where we can pick the values of x and y. मैं x और y कहाँ से लूँ? 1 लिया, कभी मैंने 1 लिया, -1 लिया. In this example, I had picked x as a 2, y as a 3. So there must be some of the domain with us from where we are supposed to pick the values of a variable, and that domain, that particular set from where we are picking the values of a variable, that set will be known as a domain or discourse of domain. ठीक है, तो उसको हम बोलेंगे कैपिटल डी। कहाँ चलिए लेके जाता हूँ, पर उससे पहले डिस्कस करते हैं क्वांटिफायर। अब बिफोर डिस्कसिंग दैट, जस्ट गिव मी 1 minute बिफोर गोइंग फॉर द क्वांटिफायर्स। That is the next unit, but wait for 1 minute. Let me pick one of the suitable example related to this. Just give me 1 minute. Hopefully यहाँ तक किसी को डाउट है? Hopefully all of you are comfortable up to this. If you are having any query, then please let me know. Please let me know. और if you are good, तो भी आपको बताना है। जल्दी से चलिए, जल्दी से drop a message on the chat box. You may use the chat box. All those who are attending this are supposed to reply or the chat box whether he or she is good or not. All those who are attending this, I said all those who are attending this are supposed to reply on the chat box. यहाँ तक कोई प्रॉब्लम है नहीं है। Now, if I'm going to discuss one of the example with more than 2 variable, predicate with 3 variable, let me pick a blank screen and let me pick my pen. Suppose I'm defining one of the predicate like this, p of x comma y comma z, and it stands like that. I cannot write equal to, okay, that x plus y is equals to z. X plus y is equals to z. Now, if suppose, first of all, understand that this is a predicate, or in other words, we can say that it is a propositional function with 3 variable x, y, and z. And I'm declaring one of the statement over here that x plus y is having value z. X plus y, the addition of x and y, is equals to the z. So I'm declaring some of the thing, and all can easily understand the truth value of this. The truth value of this is that will be true or false. That's purely depend on the value of x, y, and z. Is it? So if I'm gonna pick x as a 1, y as a 2, and z as a 4. If I'm going to pick x, y, and z as 1, 2, and 4, then this statement will look like this. 1 plus 2 is equals to 4. Now, we can easily calculate, we can easily understand whether this, the truth value of this statement, this declarative statement is true or false. This is false, is it? This is false. So I can write like that, p of 1, comma 2, comma 4 is false. Is false. Is it? And if I'm going to pick instead of 1, 2, and 4, if I'm picking 1, 2, and 3, 1, 2, and 3, then surely this declarative statement will look like this. 1 plus 2 is equals to 3, which is true. So I can write like this, 1 comma p of propositional function with 3 values 1, 2, and 3 is true. Is it? So this is what the predicate with more than 2 variable. Is it? 3 variable का यहाँ पे use किया. In the earlier question we had used 2 variable. Before that we had discussed the predicate with the single variable. कल एक और बात हमने की थी. Suppose I'm using on the predicate like that, x comma y, p of x comma y, where x is capital of y. X is capital of y, and I'm picking 2 different cities over there. One of the city and one of the country that कल हमने जो लिया था, that is Rajkot, and y is suppose Gujarat. Then the declarative statement will look like this: Rajkot is capital of Gujarat. Rajkot is capital of Gujarat, which is false, is it? But if I'm gonna pick Gandhinagar and Gujarat, then that predicate is true, is having truth value true, is it? So once we are good with the predicate, what we mean by a predicate, it is a declarative statement whose truth value is dependent on the variables which we are going to include in that. So this is what the predicate is. Now we need to go for some of the quantifiers. Now First, that is universal quantifier. Universal quantifier. Now, what we mean by universal quantifier? किसी को पता भी है कुछ भी इसके बारे में? मेघना? मेघना? थोड़ा इसका, मेघना आयुध है? ओके,
Yes,
मेघना
sir.
अनम्यूट रहे, मेरे साथ बात कर। यूनिवर्सल क्वांटिफायर, थोड़ा इसका मीनिंग पकड़ने की ट्राई कर।
Yes,
यूनिवर्सल,
sir.
क्या कोई ऐसा स्टेटमेंट तू मुझे बता सकती है जो हर बार सही है?
Sir, the sun rises in the east.
या सन राइजेस इन द ईस्ट, इज इट? बट
Yes, sir.
वहां पे कोई उस वाले स्टेटमेंट में कोई वेरिएबल है नहीं, ठीक है?
हाँ sir.
कुछ एक ऐसा स्टेटमेंट बना जिसके अंदर वेरिएबल भी हो और हर बार उसकी वैल्यू सही आ रही है। हर बार उसकी वैल्यू सही आ रही है।
सर वेरिएबल में तो हम जितनी बार वैल्यूज लेंगे हर बार वैल्यूज अलग आएगी ना।
हाँ, पर वो हर बार सही आनी चाहिए। ऐसा कोई प्रेडिकेट बना पाएगी तू? देख, पी ऑफ एक्स, थोड़ा सोच, थोड़ा मेरे साथ रहे, ठीक है?
Yes.
एक्स स्क्वायर इज पॉजिटिव if x belongs to real number r। क्या लगता है तुझे,
हाँ सर।
ये सही होगा? इज इट?
हाँ सर।
इज इट? x belongs to r प्लस, ताकि जीरो भी निकाल दूं, चल मैं जीरो वाला केस भी ना आया कि वेदर जीरो इज साइन वाइज न्यूट्रल, वो पॉजिटिव नहीं, नेगेटिव नहीं, वो न्यूट्रल है। बट if I'm saying x belongs to r plus and x square is positive,
Yes sir.
then we may write like this: for every x, p of x is true. Is it? For every x, p of x is true. हाँ या ना?
Yes sir.
ये सभी को ये all of you are good with this sign? उल्टा है जो हम लिखते हैं, what is this? This is for every x. For every x. इसको wording में ऐसे बोला जाता है, for every x. And if I'm using this notation, तो इसको क्या बोलते हैं हम? There exist some x. There exists some x. Is it? फिर एक और नोटेशन आता था आपके 12th में, इट वाज लाइक दिस, सच दैट। ठीक है, तो तीन नोटेशन है, देखिए याद रखिए यहाँ पे क्वांटिफायर में। फॉर एवरी, देयर एग्जिस्ट एंड सच दैट। ठीक है, नाउ वी आर गोइंग टू डील विद बोथ दिस, फॉर एवरी एंड देयर एग्जिस्ट। अब इन दोनों को जब मैं इंक्लूड कर रहा हूँ प्रेडिकेट में, based on that we'll be classifying it as a universal quantifier or essential quantifier. What is this? This is a universal quantifier and this is a essential quantifier. ये होगा हमारा universal quantifier और ये होगा हमारा essential quantifier। ये तो उन दोनों की बात कर रहे हैं हम नेक्स्ट स्लाइड में। चलिए लेके जाता हूं आगे। यूनिवर्सल क्वांटिफायर, थोड़ा साथ में रहना। The universal quantification of p of x statement. The universal quantification of p of x statement. What is p of x? P of x is one of our predicate. That p of x for all x belongs to D. Now, what is D? D is actually a domain. D will be a domain or discourse of domain. कुछ भी बोल सकते हो उसको। The universal quantification of p of x. It will look like that: p of x for all x belongs to D, and the D is what? D is called domain, or हम बोल सकते हैं domain of discourse. Then it will be denoted as for every x p of x. For every x p of x. Now, for every x p of x is true. अब इसकी वैल्यू true कब होगी? If p of x is true for every x in the domain. Domain में से कोई भी x उठा लो, वो p of x की वैल्यू सही होनी चाहिए। Is it? Then we can say that for every x p of x is true. कब हम बोल सकते हैं p of x कोई predicate true है with the use of this particular universal quantifier for every x? अगर हर एक वैल्यू के लिए if that p of x stands true for all the values of x from the domain, then and गलत कब हो सकता है? गलत when I can say that p of x for every x p of x is for every x p of x is false. ऐसा मैं कब बोल सकता हूँ? Is false if I'm having a single evidence. If I'm having a single evidence that for one of the value of x that p of x is wrong, p of x is having value false. तो वही बात है. चलिए यहाँ पे थोड़ा कंफ्यूजन इसके बीच में ही रहेगा आपको कि कब सही कब गलत, पर एक छोटे से एग्जांपल से वो मैं क्लियर कर दूंगा. पहले ये दोनों देख लेते हैं. Yes, be with this. For every x, p of x is true if and only if p of x is true for every x from the domain. In the domain, domain means B. B में से कोई भी x आप चूज कीजिए, and each and every time that predicate is having truth value true, then that statement, that universal quantification of predicate is true, and that universal quantification of predicate is false if p of x is false for at least one value of x in the domain. कोई एक के लिए भी अगर वो गलत है ना, बात खत्म. that universal quantification will stand false. अब ये कैसी बात हुई? अब ये कैसी बात हुई? राज आयुदय, राज तू यहाँ पे है बेटा? राज पंजवानी, आयुदय, मेघना देख तो राज है कि नहीं है?
सर वो नहीं है, उसकी कोई इंटर्नशिप है.
ठीक है, कोई बात नहीं. I need one other person.
Sir,
who will help me? I need
sir,
one
राज
other.
है सर.
ऋषभ है. पहले तो छोड़ राज को, छोड़, तू यहाँ पे रहे. आज
अच्छा.
तेरे माइक का इश्यू नहीं है, बहुत बड़ी बात है.
हाँ सर, वो ड्राइवर्स रोल बैक कर दिए थे मैंने.
क्या बात है? तो ये तो तू कितने दिनों पहले कर सकता था.
अरे सर, मेरे को पता ही जब चला ड्राइवर इशू है तब मैंने करा.
तो कंप्यूटर इंजीनियर बनने वाला है और तुझे पता भी नहीं कि ड्राइवर इश्यू कैसे सॉल्व होता. अब तक तो मुझे कभी कभी ऐसा लगता था कि तू मुझे वो बस मामा ही बना रहा है.
अरे
ठीक है,
है
चल
सर.
छोड़ वो बात, साथ में रहे. क्या बात कर रहे हैं हम? देख ऋषभ, अभी we are discussing about the universal quantifier. What is universal quantifier? Universal quantifier is this for every x. This is our universal quantifier. Now for that, to identify the truth value of that, what I'm doing, I'm forming a universal quantification of one of the predicate. Now universal quantification of one of the predicate, it will look like this for every x p of x. Now the truth value of universal quantification will stand true if that p of x is true for all the values of x in the domain, and the truth value of that universal quantification will stand false if we are having a single x from the domain for which that predicate is having the value false. Is it? अब इसको जब समझ रहे हैं हम, बहुत ही एक छोटा सा और सिंपल सा रास्ता हम ले ले. अगर मुझे प्रूव करना है कि ऋषभ वो, suppose I'm declaring one of the statement Rishabh ki like that. Rishabh is having a similar characteristic as Raja Harishchandra. राजा हरिश्चंद्र के बारे में सुना है तूने ऋषभ?
नाम सुना है सर.
The great king in Indian history, राजा हरिश्चंद्र. किसी ने सुना है? किसी ने भी सुना है हरिश्चंद्र का नाम? Any of you had ever heard about Raja Harishchandra, king?
Yes.
किसने सुना हुआ है? कोई एक अनम्यूट करो. कोई
सर मूवी थी उतना पता है.
हाँ राज अनम्यूट कर तू भी. ऋषभ तू भी अनम्यूट रहे. राज तू अनम्यूट कर. या देख, राज पालीवाल ने बोला he always used to speak true.
हाँ, सत्यवादी हरिश्चंद्र.
सत्यवादी राजा हरिश्चंद्र. अब तुझे आया याद?
yes,
अब ऋषभ हम क्या कर रहे हैं? हम तुझे इक्वेट कर रहे हैं. तुझे मैं ऐसा डिक्लेयर कर रहा हूं कि ऋषभ इज having a same characteristic as राजा हरिश्चंद्र. This is one of my declarative statement. Okay, ठीक है.
yes, sir.
जैसे कि हम अभी बात कर रहे थे कि x is divisible by
y square
और divisible by 7 सिंगल वेरिएबल के साथ ले रहे p of x. ठीक है.
Okay.
अब इसी तरीके से आई विश टू जज कि ऋषभ इज इक्विवेलेंट टू राजा हरिश्चंद्र. पर मैं क्यों ऋषभ की बात करूं? मैं काफी लोगों की बात कर सकता हूं. So let me define one of the statement like this. मैं एक predicate ऐसे डिफाइन कर रहा हूं. p of x single variable. X is having similar characteristic similar to Lord Raja Harishchandra. LRH stands for the Lord Raja Harishchandra, ठीक है. And from where I'm supposed to pick my x कहाँ से pick करना है वो भी मैं decide कर लूँ कि x I'm gonna pick from the 4TP1 TO1. इसी में से मुझे x को pick करना है, nothing else, कहीं और से pick नहीं करना है. अब मुझे सिर्फ देखना है ऋषभ के बारे में. सपोज कि ऋषभ इज हैविंग सेम कैरेक्टरिस्टिक विद द राजा हरिश्चंद्र और नॉट. तो मुझे क्या करना होगा? आई नीड टू असेस यू फ्रॉम योर चाइल्डहुड. ठीक है कि जब मैं छोटा बच्चा था, जब ऋषभ छोटा बच्चा था 1 साल का, तब भी वो कभी झूठ नहीं बोला. 2 साल का हुआ तब भी झूठ नहीं बोला. अभी वो 20 साल का हो रहा है, कभी भी अब से कभी भी वो झूठ ही नहीं बोला. He never speak lie. Is it? वो हर बार सच ही बोलता है. I need to check for each and every time. But अगर हर बार मुझे ये मिल रहा है कि नहीं, ऋषभ कभी झूठ बोलता ही नहीं है. ऋषभ ने बोला था कि मेरे माइक का इश्यू है, सच बात थी. ऋषभ बोल रहा है ड्राइवर का इश्यू था, सच बात थी. Is it? हम मान रहे. So if I wish to prove that कि you are having same characteristic as Raja Harishchandra, then I need to provide proof for each and every time. But if I'm going to prove that कि ये वाली बात गलत है, तो क्या करना पड़ेगा ऋषभ? क्या मुझे हर एक बार चेक करना पड़ेगा कि कभी तो
कोई भी एक गलत पॉइंट चेक कर लो.
कोई भी एक दिन पकड़ लूं मैं कि ऋषभ कल तू बोल रहा था कि ड्राइवर का इश्यू है, पर वो तो सच में है नहीं. तो कल तू एक दिन झूठ बोला था. If I'm having a single evidence which is against to this, then we are done. So this is what. Yes, please.
फिर नहीं होगा वो यूनिवर्सल प्रेडिकेट.
So इसी के बारे में बात है, इसके बारे में बात करें. So universal quantifier के लिए we need to check for each and every value from the domain. It should have the truth value true for every x in the domain. But if we want to prove that it is a false, अगर वो गलत prove करना है, then we will be just looking for a single value from the domain for which that predicate is having the value false. ठीक है? So इस तरीके से हम universal quantification की value decide कर पाएंगे whether it is true or false, and this particular quantifier for every x is known as universal quantifier. Take care for that. Let me take you further. वही वाली बातें देखिए, अभी स्क्रीन के ऊपर है वो. The x for which for every x p of x is false is called the counter example. We'll be saying जिसके लिए वो गलत मिल रहा है, for which that p of x stands false, that x will be known as a counter example for this particular universal quantification. ठीक है? पर और एक important बात है ये वाली. I can set MCQ based on this. Take care for that. If domain is a null set, if the domain for that particular predicate is null set, अगर उसका domain ही null set है, मुझे पता ही नहीं कि किसके बारे में x की वैल्यू क्या लूँ, वो x की वैल्यू जहाँ से लेनी है, that particular set is null set. If that domain is null set, then that universal quantifier is by default true. And that universal quantifier is by default true because of the lack of evidence. क्योंकि हम नहीं प्रूव कर पा रहे कि वो गलत है. If we can't prove that it is false, then we need to accept it's that universal quantifier, that universal quantification is true by default true. Okay. So here is the case which we can compare with the lack of evidence. Is it? If the domain is null set, then we will be always accepting yes, the truth value of that universal quantification is always true. So take care for that. I can set MCQ based on this. इसके ऊपर मैं कुछ शॉर्ट क्वेश्चन या MCQ डाल सकता हूँ. चलिए 1-2 एग्जांपल देखते हैं. Observe here. Just first of all, don't worry about the solution. Solution will be quite easy. Just first of all, we need to understand the question properly. Observe, this is one of the predicate. P of x, predicate with the single variable P of x, declarative statement is like that, x square is greater than 10, x square is greater than 10. Now what we are supposed to do then, what is the truth value of this universal quantification? What is the truth value of this universal quantification? Observe here, this is P of x is my predicate. I'm associating that with for every x P of x. For every x P of x is my universal quantification, is it? And we are looking to check whether this universal quantification is having truth value true or false. But when someone is asking that determine the truth value of universal quantification, then your first question must be that, your first question to that person must be that, provide me the domain from where I'm supposed to pick the x, from where we are supposed to pick the x, is it? So we must have the domain. So I'm giving you 3 different domains. First, if your domain is real number. Second, if your domain is one of the set, one of the finite set who's having 4 elements only, 1, 2, 3, and 4. And the third case, if the domain is the real number from 11 to 20, from 11 to 20. Now, for which of the domain the truth value of this universal quantification will stand true, and for which of the domain the truth value of this universal quantification will stand false? चलिए आप बताइए, take your time. Question नहीं समझ में आ रहा है तो please ask me, and if you can, then please let me know. All of you are comfortable with the question? All of you are comfortable with the question? समझ में आ रहा है सभी को क्या बात कर रहे हैं हम? देखिए इसमें प्रॉब्लम ये है कि ये बहुत ही आसान है, इसलिए ये कंफ्यूजन है. दिस पार्ट इज वेरी वेरी इजी फॉर ऑल ऑफ यू, सो दैट माइट बी द रीजन कि आपको लगे कि सर क्या ये इतना आसान नहीं हो सकता. हाँ है, पर ठीक है. सो आर यू गुड विद द क्वेश्चन? पहले ये बताइए, क्वेश्चन समझ में आ रहा है सभी को? क्या करना है क्या नहीं करना है? So the courtesy, drop a message on the chat box. I'm just getting 2-3 replies on the chat box. It's not done. All those who are attending this, I will reply on the chat box whether you guys are comfortable with the question or not. Solution की बात बाद में करते हैं, पहले question कितनों को समझ में आ रहा है ये बताइए. Mohammed, unmute yourself. Mohammed, unmute yourself. Sir, I have mic issue today. Okay, Mohammed. It's a rare answer from your side, but it's fine. Daredi, unmute yourself. Daredi. It's fine, Mohammed. Daredi.
Yes,
Nikita
sir.
Daredi.
Yes, sir. Yes, sir.
Hostel में छो कि घरे छो?
Hostel में, sir.
Okay. Things are good around you?
Yes, sir.
Okay, good. Question समझ में आवे छे? शुरुआत करिए छी. Universal quantification, predicate. We are looking to check the truth value of one of the universal quantification where you are using for every x p of x, is it?
Yes, sir.
And you are supposed to assess this particular universal quantification on 3 different domains. If your domain is real number, that is first. If your domain is a finite set 1, 2, 3, 4, and if your domain is a closed interval 11 to 20, that means all real number between 11 and 20, from 11 to 20. I cannot say from 11 to 20. तो चल क्या लगता है तुझे दरेडी, यहाँ पे यूनिवर्सल क्वांटिफिकेशन फॉर एवरी एक्स पी ऑफ एक्स की वैल्यू सही किस में आएगी? फर्स्ट वाले में, यहाँ पे फर्स्ट डिस्कस करेंगे, यहाँ पे सेकंड, यहाँ पे थर्ड. चल क्या लगता है तुझे दरेडी? बी विथ मी.
Sir, first में.
If I'm picking x as a 1, then what will be p of x, dear? P of x will be 1 square greater than 10. 1 square is 1. 1 is greater than 10. Whether
Sir,
it is correct.
Third में आएगी सभी सही.
First of all, be with this. Whether it is true or false, this is false, is it?
Yes, sir.
So I can write like this: for every x, p of x is false for b equals to r, is it?
Yes, sir.
When you are declaring that the truth value is false, you must have at least one counter example. आपके पास कम से कम एक counter example होना चाहिए. तू किसी को ना बोल रही है, तू किसी को बोल रही है कि तू झूठा है, तू गलत है, तो यू मस्ट हैव वन ऑफ द एविडेंट विथ यू ना, वन ऑफ द एविडेंस विथ यू।
Yes, sir.
सो हमारे पास काफी एविडेंट है यहाँ पे। इफ यू टेक x इक्वल्स टू 2, तो
Yes.
2 द स्क्वायर 4 भी 10 से बड़ा नहीं है। इफ यू आर टेकिंग x इक्वल्स टू 3, तो भी वो 3 द स्क्वायर इट विल बी 9, 9 इज नॉट ग्रेटर देन 10। सो काफी सारे एविडेंस है हमारे पास, ठीक है। सो किसी को गलत बोलने से पहले काफी एविडेंस होने चाहिए, है कम से कम एक होना चाहिए, हमारे पास एक से ज्यादा है यहाँ पे। So the truth value of this will be false. Now, what will be the case if we are dealing with this particular set? अब देखना यहाँ पे ये केयर करना कि तेरे पास सिर्फ 4 ही एलिमेंट है, 1 2 3 4, ठीक है। यू कैन पिक योर x फ्रॉम दिस 4 ओनली। अगर मैं 1 ले रहा हूँ, बात गलत है, 1 द स्क्वायर इज 10, खत्म, एक एविडेंस मिल गया। If I'm picking x equals to 4, if I'm picking x equals to 4, then x square is greater than 10, ये वाला predicate जो है p of x, it will stand true, तो ये true होगा, p of 4 is true। पर just because कि कोई एक के लिए p of x सही है, p of x की वैल्यू true है, we cannot say that for every x p of x is true, नहीं बोल सकते ना।
Yes, sir.
So this is false once again in the second case. Now, what will be the case if I'm picking my domain as 11 to 20, close into 11 to 20, then 11 the square,
The big. Yes.
surely greater than 10. Even if you may pick 11.1 the square will be surely greater than 10, ठीक है। कोई भी ले ले between 11 to 20, each and every time that p of x will have that predicate p of x will have the truth value true. So we can say that for every x, p of x is true.
True.
If x belongs to the domain which is 11 to 20. Are we good? Are we good?
Yes, sir.
Let me show you the proper solution. Just go through it, all of you. All of you just go through it. And drop the message on the chat box कि समझ में आ रहा है नहीं आ रहा है। All those who are attending are supposed to reply on the chat box after getting this, after going through the entire slide. बहुत ही आसान है, it's very easy, okay guys, it's very easy. Is it? So let's continue further. Now try to evaluate this. Let's say predicate as p of x is an even number, then 2x plus 1 is always an odd number. Now this is one of our declarative statement, and we all know that what is a predicate? Predicate is actually the declarative statement whose truth values depending on one or more variable. This is a predicate with the single variable p of x. This is a predicate, x is an even number. Then 2x plus 1 is always an odd number. This is a predicate, and I'm giving you the domain like that. Domain d is equals to n. What we mean by n? N is a set of all the natural number. That means 1, 2, 3, 4, 5, 6, up to infinite, is it? You cannot pick x as a 1.1 because 1.1 is not the part of n. So n, the set of all the natural number, that will be your domain. And you need to determine the value of this universal quantification for every x p of x. So giving you 1 minute, go through it once quickly and let me know whether this particular universal quantification will have truth value true or false. Next चलो तो 5 मिनट म्यूट कर दीजिए बोल तो હું 3 મિનિટ 5 મિનિટમાં કરું છું ઓકે ફ્રી છો તું 5 મિનિટમાં કરી શકું હાલ 5 મિનિટ 5 મિનિટમાં કરું 5 મિનિટ May I know what will be the truth value of this universal quantification? Let me go through the chat box. True. Correct. Show you the solution. If you pick any of the natural number, any of the even number, the restriction is over there. On x, you can pick even number only as x. Is it? If I'm picking x as a 2, then 2x plus 1, it will be 5. If I'm picking x as a 6, then 2, 6 are 12 plus 1, 13. The 2x plus 1 will always stands odd if we are picking x as an even number. So, but if we are picking x as a 3, then it will be an even number. Is it? Or odd number? In any of the case, it will be odd number because it is 2x plus 1. But there is a restriction on x. So yes, this particular universal quantification is true. P of x is true. So for every x, P of x is true. So this particular universal quantification or this particular domain, natural number, is always true. So this is the way we can use our universal quantification, universal quantifier for every x. Now it's already 12. Let me stop the recording. Okay, before ending the session, 57 are present in front of me in this particular meeting. I will request, I'm not gonna request, sorry. There is an information for all of you that the last session of the day, that is from 2:55 to 3:55, that will be delivered by me again. Instead of Winkle ma'am, I will be delivering the last session of the day. The separate link will be there in your calendar within a short time. So all of you will join this session from 2:55 to 3:55. Then and then I will give the attendance of both the session. Okay. So let me stop the recording. Thank you very much. We are